Hi, I'm Dr. Archana. Today we'll study or take up a very important concept in chemistry known as thermodynamics. Thermodynamics is a very important chapter from board exam, competitive exam point of view, and it plays a, an immensely important role in our day-to-day life as well. So, let's begin. Please get your pen and paper, and I'm sharing my whiteboard. Thermodynamics. We know that chemical energy is stored by molecules which can be released in the form of, say, heat when fuel like methane, cooking gas burns in air. We also know that chemical energy can get converted into mechanical energy when fuel burns in a engine of a vehicle. The same chemical energy can be converted into electrical energy in a galvanic cell. So, if we were to define thermodynamics, it can be defined as follows. Thermodynamics is the study of energy transformation for macroscopic systems. Why did I say this? Because various energy forms are interrelated and can be converted into one form to another. I'll give you a day-to-day example. Suppose if you have a hot iron rod, very hot, red hot, and you place another cool metallic strip at that, the hot iron rod transfers its heat energy to the metallic strip which was at normal temperature. So, heat energy from one rod got transferred to another rod. Again, in this case, in the form of heat. Second, if we were to have a look at a waterfall, what we can see is that water always falls from a point at higher energy level to the ground. Why this is so? Thus, thermodynamics, it deals with energy changes for any particular reaction. Could be a chemical reaction, could be a biochemical reaction happening in our body. It will ascertain the driving force for that chemical reaction. It will also tell the extent to which the reactions will proceed. Suppose you have a reaction A and you have a reaction B. For example, if I were to boil water, it boils at a specific temperature, 100 degrees Celsius, and then gets converted into vapor. So it will tell, thermodynamics can tell that water will get converted into vapor. It will also tell that petrol, if it is present, open can of petrol is present in the sun, it will evaporate. But it will not tell that the water will evaporate or boil at a slower rate as compared to petrol. That means it will just tell that whether this reaction is feasible or not feasible. It cannot tell the rate at which that particular reaction occurs. So that is told by another section, that is that aspect is addressed by another section known as chemical kinetics. But thermodynamics will be responsible for telling us or for ascertaining the energy changes, the driving force, and the extent to which the chemical reaction will proceed. So, let us define few thermodynamic terms. The first thermodynamic term is system. So, System is that part of the universe under thermodynamic study. Is called as system. Surrounding. The part of universe could be any object in the universe excluding the system is surrounding. So system and surrounding equal to universe. Suppose I have a beaker which contains A plus B. So this A plus B reaction mixture is known as system. The part of universe in the neighborhood of the system. That means all this is neighborhood of the system is surrounding. This reaction mixture is system and the neighborhood of the system is surrounding. So generally the system is defined by a particular set of Cartesian coordinates so that one can track the movement of matter and energy in and out of the system. Now there are different types of system. In fact, there are three prominent type of system. You have a open system, you have a closed system, and you have a isolated system. Let me explain these three types of system with the help of an example. Suppose you have a beaker and you have another beaker and you have another beaker. You have three beaker like this. And in this you have reaction mixture. Right? You have reaction mixture in all of this, which is denoted by this blue color. The first system, I call it as A. Second one, I call it as B. And third one, I call it as C. So, over here, blue color is your system. Now, the first case, you can have matter. That is whatever reaction mixture, it can evaporate and go into the surroundings. So, there is exchange of matter and there is exchange of energy. Both are possible. From the system to surrounding and from surrounding to system. Hence, it is called a open system. In the second case, you have beaker and the same reaction mixture, but you have on top of that, you have this lid, which I am showing by yellow color. So you have this lid. Now, in this system B, energy can be exchanged, but matter cannot go from within the system to the surrounding and vice versa. So, it is only exchange of energy is possible. Hence, it is a closed system. The third case, again you have a lid on top of that. Apart from this system is insulated from outside. Because of this insulation, there is, like you have seen a thermos flask. It has a lining outside the container. So something akin to a thermos flask. So in this, again, this is insulation. And this is my lid. Okay. So neither energy nor matter. First case, both energy and matter, open system, can be exchanged. Second case, only energies can be exchanged. Matter exchange is not possible. Third case, neither matter. Here, matter, energy. Both of them, no exchange. No exchange of matter over here. Let me specify it. So, the third case is a case of isolated system. Thus, I can define open system is a system where both exchange of energy and matter is possible between the system and the surrounding. So it's called an open system. Closed system, only exchange, a system in which only exchange of energy is possible between system and surrounding. That's a closed system. The system in which, the third case, neither energy nor matter can be exchanged between system and surrounding. That is called a isolated system. So these are the three major types of system in a thermodynamics system.